Okay, here in part 2, I am still talking about the gear and what I'm going to be doing regarding the grease. So, to put in the planetary gears. So I hope you enjoyed the video. And on the internet, everyone says to use food grade grease, okay, which is a white color. I will not be using the food grade grease because the factory never used that, okay, and it's only going to have a light grease here. Even if you had the food grade grease, you're not going to fill it up to the top or it's going to leak out. Okay, you don't want that either. So it doesn't need food grade grease. In actual fact, the food grade grease is not good enough to take loads, high pressure load. It's not good for that. So I will not be using that. I'll be using either a graphite grease or a lithium bearing type of grease, which can take a lot of load. Because here it is loaded under load when you're mixing cakes. And it's only going to be just around the gear, just a little bit. Anyway, you saw the original. When I took it off, it didn't have much grease in there anyway. So gave it a clean, and that's all the grease is going to get. Unfortunately, I thought I had some graphite grease, but I ran out. So that's all the grease is going to get, and it's a thick grease and high temperature. And I just some grease around the gear, okay? That's all. And I don't think that would leak out. Okay, it will stay there. So now it's a matter of, so wipe this off from there. Matter of fitting it. And I will be doing that now. What I want to do actually, I just want to clean around the shaft where I might put the retainer. I don't want any grease there. Okay. Just want to make sure the washer is right in the middle while the shaft tries to sink a little bit down, because that might not fit properly if you don't align the shim. Okay. So there you go. So I'll do a bit of a test. To make sure that when I tighten the nut, the hub is not tilted to one side. Okay. So looking at that, it's pretty good. I've got the same gap all around. That means the hub is straight, unlike before I took it apart the first time. So I'll give this a turn. Okay, so I am getting some grease that's coming out. And what I will do is I'll take that off again, okay, and give it a clean, because maybe I still put too much grease. Okay. Okay, so I'll take that off again and I'll clean, take some more grease off around the edges. Okay. If this wasn't a food processor, I would not take it apart again. I'll just wipe it from the outside and that would be it. It was a normal machine, but because it's food, I will do this. But eventually the grease will not come out anymore. That's because it had too much. Anyway, I'll do some cleaning and put it back. And on the nuts, I'm putting 242 medium strength blue Loctite. Okay. And I put an O-ring here. You're supposed to have a plastic washer, apparently, but I don't have that, so I put an O-ring instead. And just assuming that's so no grease will come out from that section. So that should squash. And creates a seal. So as you can see, I got the same gap all around. Okay, I'll get a bigger spanner to tighten that. Okay, so here I have the motor of the Kenwood machine, and I'm going to be dismantling it just to clean the bearings and the contacts of the switching. But before I do that, I've got a small oscilloscope here hooked up across the switch, the speed switch, which is regulated by a governor here inside where you see that bend there, and it's got a couple of weights at the end, which is a centrifugal system. So the more the motor speeds up, the more that point. So just to show, it's got this section here. Let me zoom in. That little end there, okay, which pushes the switch here. The switch is here. The faster the motor spins, the more this comes out. So it will come out and opens the switch. Okay, when it starts, the switch is in the closed position, which means the motor gets the full current on the windings. And when it hits a certain RPM, that will open the switch. Therefore, the current will go through the resistor, which is being limited, and obviously the voltage starts coming down. The motor slows down. So it's off and on, because as soon as it slows down, the speed lowers, so this section will come down again. Okay, therefore the switch gets closed again and gets full power again. So it's like it's chopping the circuit. Okay, it's like an oscillation there. instead of having an electronic similar to a pulse width modulation system for the variable speed. It's mechanical by the centrifugal governor here, which switches off the switch and therefore the motor is not getting full power constantly. It's switching. But also we'll see how much arcing there is when the switch is switching. It depends on what speed it's doing. And then when I take it apart, I will clean the contacts and I will check the capacitors, which the capacitor has got at least one capacitor there that is to cut the noise and filters the spark with a choke. So it's got a small winding coil to limit the current and noise when the switch opens and closes. So, and also on the oscilloscope, you're going to see when the switch is closed, you will see a straight line. That means it's nothing because the oscilloscope, the probes are hooked up across the switch. And when it's switching, you will see the wave going through the resistor, the circuit going through the resistor. So you see the switching on it. So that's when the switch is switching off and on, and you can see there. Right, so there's the switches switching off and on. And you can hear the motor as well. So there is still switching. And now it's completely at full power. Now it's switching. And I'll zoom in to see how much sparks is being on the switch. So let's see if we can see that. There it is inside. So now it's fully closed. There it's fully closed, so it doesn't matter. So we'll have to clean those switches, the points on the switch. Not switches, it's one switch actually, it's just 2 points, like similar to points on a car. And then, how I said, I'll check the capacitors and see if that can be improved a little. Okay, so before dismantling the motor, I'm going to take I'm going to take this measurement here, okay, which is this adjustment here, this spring. It's got two, one on each side, okay, is adjust the distance of the switch here, of the whole mechanism. So when you turn the speed, okay, you're altering that. So as a guide, in the off position there, I'm going to measure the distance here. Okay. Hang on a minute. Then I'm measuring around 14 millimeters. This is just a reference. So when I put it back together, I have to unscrew all this. I'll start around that point. And then in the end, I will calibrated according to the instruction manual. So that's that. So now I can unscrew this. It's got a lock on the head of the screw. This part is a lock, so the screw cannot turn with the vibrations. The head is a hexagon. Make sure not to lose the springs. Let's just screw out. Okay, so that's off. And on this side, it's got two screws that holds the switch. I already took them off. Two screws from this side, one there, and one there. Okay, so now this should come out, and it does. And of course, the wires are still soldered. I'll have to see whether I really need to unsolder this. If not, I'll just leave it, because so in here, if we could zoom in, this is a nylon part that there's the switch there, opening and closing. Okay. There it is. Okay. I'll have to see that contact, how it is. Looks a bit dirty. Okay. And that's pushed. Can zoom in by this end, which looks like it's a little ball bearing there, or polished. I have to see. That pushes onto that nylon section, and they're the counterweights. Centrifugal. When this speeds up, this will lift out. So we'll lift this way. So that's that. It's got an Allen key here to remove the governor. How far is the governor? The distance from the end. Yeah. Okay. So the Allen key for this is 332. And I'm not showing. Okay. So 332, and that's very tight. And now it's undone. Now, from what I could see, it goes all the way in. So across probably the end. Okay. And just by the looking of that, let's see. There's my other glasses. I could see that this being, if you could see on the shaft, looks like it's been taken off before a few times. You see different markings where it was tightened, which tells me this somebody have worked on it before. Most definitely. Most definitely. And I know it's not me that worked on this. So yeah. So not to ruin the bearing, the bush is I will clean any burrs off the shaft there, okay, before taking it off. Otherwise, it might scratch the bush. Okay, you see how we go with that. Just got to remove the brushes. Now the brushes, as you recall, I have removed them before. Let's see if I could mark these. I'm going to put a cross there. And which way they're going. That's the brush. And I'm going to mark there with the blue. Okay. Now this one, I'll only mark one line, and the blue. Sorry, that's wrong. Okay. Now, it's got two screws here. Actually, it wasn't that tight. Let's see this one. It was tight, but not that tight. Okay, let me mark this point with that point. Though I don't think you can get that confused because it's got the slot for the wire here, so it can only go one way. Okay. Let's see. Okay, now just to remove this section. But before I do that, I would need to take this gear off here, which got a roll pin in between the shaft. So let me get a punch. Okay, so I put a bit of wood here. Hopefully it's not too tight, and I got a punch. Okay, I just changed the punch, slightly a bit bigger. I think that one was the wrong size. Yeah, now it started to come out. I wonder if I should spray some WD-40. Okay, that's better. It was a bit seized up. So now I'll have to see how I'm going to take this gear off without breaking it, because it is made out of some sort of plastic or nylon. Oh, there you go. Actually, good job. It wasn't actually that tight. Perfect. So that's that. Okay. Again, we'll clean up the bear here. That may be the punch or the roll pin. If there's any bear around on the edge of the shaft. Don't want that score in the bush. Okay. So now I will remove the screws here. And let me mark again this section with this. Of course, the text, you got to make sure if you use cleaner, it doesn't come off. When I used to work at a company that we repaired forklifts, electrical forklifts, we used to use a little punch to create a mark. So that's off. How many screws does it got? 2 or 3? 3, looks like. Yep, 3 screws. So I'm not sure if anybody ever serviced this. Though how I said, it looks like that the governor was taken off before and retightened a few times, different positions. Okay, so that's off. And now, will it slide off? Is the question. some CRC here. Some there. W40 actually. Okay. That's the armature. And geez, it feels a bit tight there. Okay, might need a bit of a clean. Let's see. To clean the shaft so we don't damage the bush. So okay, let me get a very fine sandpaper. And fine, we're talking about 1200. And we'll put a bit of oil. Okay. And we'll clean the shaft. Okay. And now, there you go. So that's off. And that's off. There's no washes or anything. The bearing looks a bit dry. The bush. And that's our armature. The commutator looks pretty good. It's got no bears at all in it. That's been wearing perfectly. But we'll give it a clean before assembly. Now it has got a washer here. Okay, but no washer there. But I would look on the manual PDF file that I downloaded from the net, and we'll see if it's supposed to have a washer there. If it hasn't, if it has, it means somebody took this apart and lost the washer, or forgot to put it on. Now, how many more washers do we have here at the motor? Just one. Make sure it's one because, yeah. Okay. So that's a part. And now we got this section. Okay. Hang on a minute. A washer dropped here. Okay, so two washers. So I see. So they're the washers. They dropped from inside, so they got stuck. They got stuck on there, on the bush. And they dropped out now. So yes, it did have supposed to have washers there, and there they are. So they go there. Okay. So there you go. Two washers there, and one washers at the front. One and two there. Okay. So I'll give this a clean, and I will oil the bushes once they're cleaned. And that's another screw there. So I'll stop here for now. Okay, so the motor wires here, just for me. I've got the red here. Okay, the resistor. The blue wire goes to this point here on the switch. There's a blue wire, and then it's got a red wire that goes to the resistor here. So let me remove those. So I'm removing the wires of the motor. One off there. One off the switch. A little bit of more solder. So that's the red long one. And we got another one here. I'll the resistor that way. It's soft now. Let's see. It looks like we got another wire. And this wire has gone very brittle. This is a yellow or brown. Okay. The wire's gone stiff. Not very good. Okay. So that part's off, the wires are off. Okay, so I've got some kerosene here, and I did take the armature off. And the reason why I did that is two things. One is I won't be able to clean around the bush properly. And I'm using kerosene because I don't want to dry 100% the felt and the bush, okay? Otherwise I would use something like solvent, shellite. These markings are going to come off, but I actually put markings with a small punch, just to make sure, put everything back how it was. And also, the other reason why I took the armature off, because the wires coming off the armature, not the armature, the field windings, the wire insulation have gone brittle and it started to crack. So I'll have to see what I can do with that. So the more I'm going to move it about, the more it's going to crack everywhere. So I remove them off the brushes. Okay. So the brushes holder, the copper channel, that's been taken off as well. So we'll clean here with a small brush. And it's good I left this to last. Okay, so it's a good job that I took the whole motor apart, because it wasn't going to last long. So what I found after inspection here is that that's where the bearing sits here. It started to have some wear there, just the edge of the bearing. And on this side, it started to burn up the shaft a little bit there. You can see it's gone blue. And it's got some wear there. That tells me that the bush have run dry. The bearing is dried up. And so this section is around where the brushes is. This is where the back part is. Okay. So if I push that in all the way, you can see where the blue is where the inside the bearing, not on the outside. This is the outside, is where the gear goes. the one I had to punch the roll pin. That's the hole. So even it's still spinning, and of course it's a bit better now. I have felt it sort of a bit tight before. Because it's a long bush, it's got a little bit of wear. I mean, the shaft, definitely, by feeling it, I could feel it's got a bit of wear there. Okay. So I think we got it just in time. I can save it. I think, you know, it's not going to be like a new one. But I'll put this on the lathe and I'll clean it up. And I'll polish it up, same as the front there. So I'll do that. The bush is not loose. Funny enough, it's not loose. Obviously, we'll have some wear. So that bush there have dried up. And that's because of the heat. And just to show you the field, you see the wire here. As soon as I moved it, let me zoom in. It has cracked. Okay. This is very brittle, and same with this one. You can see the insulation there, and it's very brittle. That goes inside the brush. That's the heat. The heat. Oh, and its age, 60 years old. So I'll have to see what I can do with this insulation here. Have to try to patch it up. Same here. The wires here as well, you could see it's gone brittle from the heat of the resistor and the heat coming off the motor. And that's the fan side, so yeah, I don't like that. Anyway, I put it on a lathe to where the governor goes, so I'm not exactly where the bearing runs, okay? So then I really want to mark it up with the jaw. And just to give me some room here as well. Otherwise I could have put it on this side, but then it's very awkward to work. I'm only going to spin it at slow speed, so I'm going to put some oil, WD-40, and I've got 1200, the sandpaper. Okay, give it a bit more speed. This looks like it's got some, I could see some sort of glue. I think that's had to do with the gear. That's the gear here. Now you see that's gone up to that. Okay. It could have been maybe retainer stuff that leaked out from there. Maybe the factory did that. So that's not actually wear. See if I could zoom in. So what you see here, that discoloration, that's maybe it was a retainer of the gear, or I don't know what that is. But the bearing runs from that point to that point. You can see from that point to that point, or in actual fact, now it will run from that point to there. Let's see. Yeah, so that's the cover. Now it goes in a bit better because I cleaned up that dirt. It's still all right. I can see, because it's such a long bush, it's got a little bit of play. You can see a little bit of play. Okay. You could see that. Of course, it's out of focus. You see, it's got a little bit of play there. You see, I'm forcing it. But the play seems to be more around this edge and around the end. So, what am I doing? Removing that. And I could see as well, if you look at the end of the shaft, where are we? Okay. Still cannot focus. It seems to have more wear around the edge. Yeah. Okay, so I'm gonna polish the shaft. So I got a bit of brasso here, and I've got a flannelette material, rag. Okay, and polish this. I can't speed it up too much because it's not really supported properly. You gotta be careful not to catch the fan. So anybody doing this, it's at your own risk. Never speed it up too much, not unless it's really supported properly on the chuck. And you don't want this flying off. You could hurt yourself really bad. So I'm only on low speed. Okay. See if I can zoom in on that. Okay. The shinier it is, the better it is. The better will wear. I mean, not to wear. So I think that's pretty good. So that's one end. Okay. This end, of course, is much better. So I think I'm only going to apply Brasso on this one. It's got a bit of a slight, very fine grooves there. So I apply the emery cloth. I mean, 1200 sandpaper. And I'll clean up a bit of the commutator while we've got it. It's got a little bit of a wear where the brushes run. So after cleaning the bearings, the bushes, it's time to oil the bushes because originally they were dry. So they got dried, and that's why it was going to have some wear on the shaft. So what I'm going to do is I'm going to heat up the oil, and actually on this one with a heat gun, I'm going to heat up a bit the bush. Okay. And I've got some engine oil here. Actually, I've got some 5W40 Paneroid, and I think this is a bit thinner than the 2050. So we're going to have some there in the container, and I'm going to warm it up. And the heating part of it will help to the bush soak the oil in it. Okay. So that's soaking, it's got the felt in there and the bush, and you can see it's soaked in the oil. And we'll leave it there for about half an hour, 20 minutes. Just to make sure it soaked all the oil. And as well, it will cool down a bit. So that's, I will be doing the same with this, same procedure, to make sure the felt and the bush have sucked all the oil inside. So that's that part. So I have the speed controller here, and I have removed the screws for the contact points, which regulates the speed of the motor. Okay, and they were very pitted. I've already gave them a clean with a needle file. Okay, and you can see how it's pitted, and this was raised up because part of this contact got welded onto this. So unfortunately, I'm not going to be filing them too much because it's not going to do anything. It's not going to help. So just got them flat where it still can meet a different surface. And if these were available, probably would change these. If you could get new ones, of course. I wouldn't put second-hand ones. And what you could do as well, after filing them with the needle file, with a very fine emery sandpaper, you will give them a clean, a polish with the sandpaper as well, to get them more flat on a flat surface. Okay, and you can also, with a rag and brasso, you can polish them up as well if you want, which will make it even better. I might do that later on, but so the speed controller now have some resistors and 3 capacitors. That's a one single capacitor, which should be 0.1 microfarad, and this one is a double capacitor, which one is 0.1, and the other part, the other capacitor inside, is 0.01. So I'll be testing that with the capacitance meter. Okay, so we'll start off with the 0.1, this big one here. Come off. And I'm measuring 0.115, so that's pretty good. It still have its value, which is slightly greater than 0.1. So that's that. And now we got this one. Okay, that's the comment on there. And okay, once I'm going to measure the other capacitor, because when I zoomed in before, you couldn't see the meter. So this is one side of the capacitor, one side of one capacitor, 1.14, so that's okay for the 0.1. And this must be 0.01, and I'm measuring 0.013, so that's okay as well. All right, so that's that. And I will check just to see if there's any major leaking through the capacitor. I've got just a multimeter here. So this is old school. I don't have a leakage tester, digital one or anything. But if you put the meter on high ohms times 10 here, okay, which I've got that with my hands, so you can see it's picking up leakage through my body, which is, it's conducting through my body, right? So it's on high ohms. So if there's any high leakage, it should show up. So I'll put that on one end and on the other one here, and you see the charging and going back to 0, so there's no leakage. Swap polarity and it should charge again, and this charges. And sorry, I hit the wrong. There you go. There's no leakage there, so that's okay. And now I'll test the other one, the other two. No leakage on that, and I'll go on the other side, and no leakage on that. You see the charging and discharging. Well, the charging actually, but there, it's charged up, so it draws a little current until it charges and goes back to 0. So if there's any leakage, that meter will not come down to 0. So they're fine. The 3 capacitors are okay. Here I have the armature. Okay. And I've noticed on some places it's got a couple of wires loose. Let's see. This one here, it's a bit loose. And I've noticed this one here. Okay. So at high RPM that could vibrate. So just to make sure, I've got some varnish here. And I'm going to put a bit of varnish on it. Just to try to lock that in. Um, Same with this one. So I'll leave that drying overnight, and it's sort of prevention cure type of thing. You just never know when you take things apart, and then something else will happen. And also, the fan here was actually loose. Was slightly not loose, but it wasn't tight enough, and it was sort of slipping. So what I'm going to be doing is, it's got these sharp points here, which is supposed to lock the fan, but it wasn't tight enough. So I'm going to put some bearing, or the sorry, not that one. Hang on a minute. So yeah, I'm going to put some of this compound, retaining compound. Okay, give it a bit of a shake, and this will should. I'm not sure if it works that good on plastic, but I think it does. So I'll put a bit of that around where the fan goes. Okay, not too much. And push the fan in. Okay. So we'll leave that anyway, it's got to dry. Well, the bearing, sorry, not bearing, but it's the retaining compound actually dries when there's no air around it. But because of the varnish, I'll leave that drying up. And after locking the fan back in, I put it back on the lathe just to make sure that's when it's turning, it's not twisted. So that looks pretty good, pretty straight, that's fine. Of course, I can do that because I have the lathe here. Otherwise, you'll have to, put it back, maybe back in the motor and turn it by hand to make sure that it's not wobbling. Being plastic, could be something like that. So you need to keep checking things. So that's okay.